Welcome to The Explainer. Today we're going to pull back the curtain on an invisible force that powers your printer, cleans the air you breathe, and, yeah, even makes your hair stand on end. It's a science that is all around us, but you've probably never actually seen it. All right, let's jump right in with what looks like a bit of science magic, right? This is a Van de Graaff generator, and while it looks like it's just making someone's hair stand on end for a laugh, it's actually showing us a really powerful, totally invisible force at work.
So what is this invisible force, and how in the world does it connect something like your hair standing up or that little zap you get from a doorknob to the perfectly printed pages coming out of an office printer? I mean, they seem like they're from completely different worlds, but they're not.
Well, the answer comes from a field of physics with a kind of intimidating name, electrostatics. But don't let the name fool you. It's really just the science of electric charges that are just sitting still. And once you get the one basic rule, you'll start seeing this force absolutely everywhere.
To understand how all of this amazing technology works, you really only need to get this one simple fundamental rule that just governs everything. Okay, so this slide right here, this pretty much tells you everything you need to know. Look on the left, you see two charges that are the same, like charges, and what are they doing? They're pushing each other away. But then you look over on the right, you've got two opposite charges, and they are pulling toward each other, kind of like magnets. That's it. Seriously, that simple phrase is the key. It's what unlocks the secrets behind so much of our modern world, and it's the core principle we're going to see in action over and over again. The official term for all this, like we said, is electrostatics. It might sound a little complex, but just always come back to that one powerful rule. Opposites attract and likes repel. That is the key. All right, so let's put this into practice. We're going to look at our first real-world example and see how this simple rule makes something we totally take for granted not just possible, but, well, brilliantly efficient. You ever stop and think about what is actually going on inside a photocopier? It's not magic. It's pure electrostatic genius. The whole process is called xerography, which is just Greek for dry writing, and it's all about controlling exactly where those positive and negative charges go. The secret sauce inside is this special stuff called a photoconductor. The easiest way to think about it is like a switch for electricity that's flipped by light. So, in the dark, it holds on to a charge, but as soon as light hits it, poof, the charge can flow away. And this slide breaks down this whole five-step dance of charges perfectly, so let's walk through it. First, this special drum gets a nice, even coating of positive charge. Then, a bright light shines onto your original document and reflects off the white parts. Now, wherever that light hits the drum, the charge gets erased, leaving behind a positively charged image of your text. Okay, next up, a negatively charged powder, that's the toner, gets sprinkled on. And what happens? Opposites attract. The toner sticks only to the positive parts. Then, a piece of paper, which has been given an even stronger positive charge, comes along and pulls that toner right off the drum. And finally, some hot rollers melt it all in place. It's all just opposites attract, but done with perfect timing. Okay, so that's how we use electrostatics to make clean copies in an office. But what happens if we take this same idea and just scale it way up? I'm talking from a small machine to a massive industrial level. We're going from making clean copies to making the actual air we breathe cleaner. What you're looking at here is a diagram of something called an electrostatic precipitator. These are huge devices used in things like power plants and factories to literally grab pollution out of the air before it ever gets out of the smokestack. So how does it work? Well, it's actually pretty brilliant in its simplicity. As all the dirty air flows through, it passes a grid that zaps all the little particles of smoke and dust and gives them a positive charge. Then, that air flows past a second grid of collector plates that have a negative charge, and you know what happens next? Opposites attract. All that positively charged soot and dust gets yanked out of the air and sticks to the negative plates like a magnet, letting the clean air flow right on through. And the result? I mean, it's dramatic. Think about a factory pumping out thick black smoke. Now look at the plant on the right using this tech. You can barely see anything coming out, because all those polluting particles have been electrostatically snatched out of the exhaust. So, just how effective is this? It's incredible, really. These industrial systems are so good at what they do, they can remove over 99% of the particles from smokestack emissions. That is a huge deal for our health and for the environment. Okay, so now that we've seen this basic principle in action in a copier and an industrial air cleaner, you can start to spot this invisible force pretty much everywhere, especially with technology you probably have right in your own home.
I mean,
Think about your home printer. Doesn't matter if it's an inkjet or a laser printer, it is a master of electrostatics. An inkjet printer shoots out tiny droplets of ink, gives them a very specific charge, and then uses charged plates to steer them perfectly onto the page. A laser printer, on the other hand, it works almost exactly like that photocopier we just talked about, but it uses a laser to draw a super precise, charged image on its drum. And you can kind of see the two different game plans right here. On the left, the inkjet is like a tiny, super-controlled spray gun that uses charges to aim the ink. On the right, the laser printer is more like a stamp, building the whole image at once with a pattern of static electricity. Two totally different methods, but both of them are powered by that same fundamental force. And it doesn't just stop with printing. This is the secret behind that flawless, even finish you see on a new car. The paint droplets get a positive charge, and the car's metal body gets a negative charge. The result? The paint is literally pulled onto the metal, wrapping itself around corners and into every little nook for a perfect coat. They use the same idea to apply those soft, fuzzy felt coatings on stuff too. So really, the big takeaway here is that this one simple rule, opposites attract, likes repel, is one of the most important unsung heroes of modern technology. From the copies you make, to the cleaner air from a factory, to the car you drive, it's just hiding in plain sight, quietly making our world work. So the real question I have for you is, now that you're in on the secret, where else are you going to spot this invisible force working its magic? Think about how dust clings to your TV screen, or maybe even lightning during a thunderstorm. Once you start looking for it, you're going to be surprised to find this elegant and powerful principle is absolutely everywhere.